Welcome to the unit on quadratics and straight lines. In this unit, we will be looking at key concepts through review exercises. The objectives for this session are to review previous topics through exercises, namely write quadratics in the form x plus p all squared plus q, find the equation of the line passing through 2 points, find the number of roots of a quadratic using the discriminant, and find the equation of the line passing through a point and perpendicular to a given line. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. We will now proceed to solve review exercise 1a. Write x squared plus 6x plus 18 in the form x plus p all squared plus q. Now, x squared plus 6x plus 18 is equal to x plus 6 over 2 all squared minus 6 over 2 squared plus 18. Notice that here we've used the completing the square method. This gives x plus 3 all squared minus 3 squared plus 18. And tidying up gives x plus 3 all squared plus 9. We will now proceed to solve review exercise 1b. Write x squared minus 8x plus 6 in the form x plus p all squared plus q. Now x squared minus 8x plus 6 is equal to x minus 8 over 2 all squared minus 8 over 2 all squared plus 6. Again, we have used the completing the square method. Which gives x minus 4 all squared minus 4 squared plus 6. And tidying up gives x minus 4 all squared minus 10. And now for review exercise 1c. Write x squared minus 10x in the form x plus p all squared plus q. So let's solve this. Now x squared minus 10x is equal to x minus 10 over 2 all squared minus 10 over 2 squared, which gives x minus 5 all squared minus 5 squared. Which is of course equal to x minus 5 all squared minus 25. Now for review exercise 1d. Write x squared plus 9x in the form x plus p all squared plus q. So let's solve this. Now x squared plus 9x is equal to x plus 9 over 2 all squared minus 9 over 2 all squared. Again, we've used the completing the square method. This equals x plus 4.5 all squared minus 4.5 squared. Which equals x plus 4.5 all squared minus 20.25. And now for review exercise 2a. You are required to find the equation of the line passing through a equals 0 minus 3 and b equals 2, 5. The points are plotted on the graph. The gradient of the line joining them is change in y over change in x. So change in y is 5 minus minus 3. And change in x is 2 minus 0, which equals 8 over 2, which is equal to 4. And substituting in y equals mx plus c gives us y equals 4x plus c. Now substitute the point 2, 5 in the equation to find c. So y equals 5 equals the gradient 4 times x equals 2 plus c. We tidy up to obtain 5 equals 8 plus c, and rearrange to obtain c equals minus 3. And therefore the equation is y equals 4x minus 3. And now for review exercise 2b. Find the equation of the line passing through c equals 8 minus 7 and d equals minus 6, 4. We plot the points on a graph and join the points with a straight line. The gradient m is equal to change in y over change in x. The change in y is 4 minus minus 7, and the change in x is minus 6 minus 8. Tidying up gives us that m is equal to 11 over minus 14. And therefore y equals minus 11 over 14x plus c. Now we substitute 8 minus 7 in the equation to find c. So we have minus 7 from y equals minus 7 equals minus 11 over 14, which is the gradient, times x equals 8 plus c. We rearrange to obtain minus 7 plus 88 over 14 equals c. And tidying up gives us that c is equal to minus 10 over 14. Therefore the equation is y equals minus 11 over 14x minus 10 over 14. And multiplying through by 14 gives us that 14y plus 11x plus 10 equals 0. And now for review exercise 2c. Find the equation of the line passing through e equals minus 3 minus 2 and f equals 6, 12. So plot the points and join them with a straight line. The gradient m is change in y over change in x. Change in y is equal to 12 minus minus 2, and change in x is equal to 6 minus minus 3. So plugging these values in, we have m equals 12 minus minus 2 over 6 minus minus 3. And tidying up gives 14 over 9. And therefore the equation is y equals 14 over 9x plus c in the equation y equals mx plus c. We will now substitute one of the coordinates on the line minus 3 minus 2 in the equation to find c. So minus 2 equals 14 over 9 times minus 3 plus c. as shown. Rearranging gives us that c equals minus 2 plus 14 over 3. And this gives us that c is equal to 8 over 3. Therefore, our equation is y equals 14 over 9x plus 8 over 3. Or multiplying through by 9 gives the equation is 9y equals 14x plus 24. The roots of the equation ax squared plus bx plus c equals 0 are found by using the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. For the function f of x equals ax squared plus bx plus c, with a, b and c real numbers and a not equal to 0, the expression b squared minus 4ac is called the discriminant. We consider first the case a greater than 0. In this case, all the quadratic functions generated will have a quadratic shape as will be shown on your screen. Now, if b squared minus 4ac is greater than 0, the function has two roots. If b squared minus 4ac equals 0, the function has one repeated root. And if b squared minus 4ac is less than 0, the function has 0 roots. Now, when we consider the case a less than 0, the quadratic functions generated will have a quadratic shape flipped in the x-axis, as will be shown on your screen. The other conclusions regarding the number of roots will be identical. So, if b squared minus 4ac is greater than 0, the function has two roots. If b squared minus 4ac equals 0, the function has one repeated root. And if b squared minus 4ac is less than 0, the function has 0 roots. So here's a summary of these points. Let's now have a go at review exercise 3a. Find the discriminant of f of x equals x squared minus 3x minus 16 and use it to determine how many real solutions this equation has. So we have that x squared minus 3x minus 16 equals 0. In the equation f of x equals ax squared plus bx plus c, the discriminant is b squared minus 4ac, which in our example is minus 3 squared minus 4 times 1 times minus 16, as shown. This equals 9 plus 64, which is equal to 73. Of course, 73 is greater than 0, and therefore the equation has two real roots. Now let's solve review exercise 3b. Find the discriminant of f of x equals x squared plus 2x plus 3 and use it to determine how many real solutions this equation has. So let's have a go at review exercise 3b. We let x squared plus 2x plus 3 equals 0. Now in the equation f of x equals ax squared plus bx plus c, the discriminant is b squared minus 4ac, which equals 2 squared minus 4 times 1 times 3, which equals 4 minus 12, which equals minus 8. And of course, minus 8 is less than 0. Therefore, the equation has no real roots. We now cover the solution to exercise 3c. Find the discriminant of f of x equals 3x squared plus 12x plus 12 and use it to determine how many real solutions this equation has. So let 3x squared plus 12x plus 12 equals 0. In the equation f of x equals ax squared plus bx plus c, the discriminant is b squared minus 4ac, which equals, in our example, 12 squared minus 4 times 3 times 12. Tidying up gives us 144 minus 144, which is of course equal to 0. Therefore, the equation has one repeated root, as shown. Before we move on to the next exercise, let's recap perpendicular lines. Perpendicular lines are at right angles to one another. So suppose L1 and L2 are perpendicular lines with gradients M1 and M2. Then M2 equals minus 1 over M1, and M1 times M2 equals minus 1. Let's now cover exercise 4. Find the equation of the line passing through 2 minus 5 and perpendicular to the line 3x minus 2y minus 1 equals 0. Now 3x minus 2y minus 1 equals 0 implies that y equals 3 over 2x minus a half. We've simply rearranged the equation to make y the subject of the equation. The gradient of this line is 3 over 2. Therefore, the gradient of lines perpendicular to it is minus 2 over 3. And therefore, the equation we are looking for is of the form y equals minus 2 over 3x plus c. We substitute x equals 2 and y equals minus 5 to find c, as shown. Which implies c equals minus 5 plus 4 over 3, and therefore c equals minus 11 over 3. This gives us that y equals minus 2 over 3 times x minus 11 over 3. This brings us to the end of this session. If you have understood its contents, you should be able to write quadratics in the form x plus p all squared plus q, find the equation of the line passing through 2 points, find the number of roots of a quadratic using the discriminant, and find the equation of the line passing through a point and perpendicular to a given line. Thank you very much for listening.